The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Thank you for joining us for this webinar, Hybrid Extending On-Premise HPC to the Cloud. We will get started in just a few minutes, so let's wait for a couple more people to roll in, and then we will begin. Thank you very much. All right, everyone, so we have quite a few people joining here last minute, so I'll give it just one more minute before we begin. So just sit tight. Thank you. Okay, I think we're going to go ahead and get started. Hi, everyone. Welcome to our webinar with Rescale today. The topic is going to be hybrid, extending on-premise HPC to the cloud. My name is Robert Combier. I'm the Solutions Marketing Manager here at Rescale, and I'm very proud to introduce my colleague Gabriel Broner, our Vice President and General Manager of HPC. Gabriel Broner has been in the HPC industry for over 25 years. He has held roles of operating systems at Architect at Cray, Vice President and General Manager of HPC at SGI, Head of Innovation at Ericsson, GM at Microsoft. Gabriel fortunately joined us as Vice President and General Manager of HPC in July of last year. I'd like to go over a couple items before we get started. First off, just so that everyone knows, we are recording this webinar and we will be distributing it at the end of the week as part of our newsletter at the end of the month. Secondly, if you have any questions during the webinar, please be sure to type them into the questions section in the GoToWebinar panel, and we will address these at the end of the webinar. Really, please don't hold back. All right, Gabriel, I'm hoping that you're all ready, and let me pass it over to you. It's all yours.
I'm ready. Can you hear me well, Robert?
We can hear you great. Thank you.
Thank you. Thanks for the introduction. Thanks, everyone, for attending this morning. I will be talking about Rescale and how we use Rescale in the world of hybrid. Our thinking is that we have been working since 2011 of HPC in the cloud, or the company has been working on HPC in the cloud. And the majority of HPC today is on-premises, and people would like to evolve their on-premise system to incorporate cloud, to extend their on-premise HPC to the cloud. So that's the main topic of today. So what I'm going to address is 3 sections. First, talk about on-premise HPC, talk about HPC in the cloud, and talk about hybrid HPC, on-premise and cloud. So first, in terms of on-premise, this is probably what Robert was saying, that was my experience. I joined Cray in 1991. I worked on the transformation within Cray to go to these massively parallel systems in the 90s. And we developed systems that were pretty much like a cluster of today, that looked like a very complex disruption at the time, going from the traditional Crays on the left to the second element, which is the massively parallel system. Then at SGI, I lived through the transition to go from operating systems that were proprietary to the Linux operating system. That in itself felt like a very unique transition, a unique disruption of the industry. Today, we're in a situation that HPC has standardized. Most systems have the similar type of architecture in the sense that they all use Intel CPU, 2 CPU nodes. They use a high-speed interconnect like Mellanox, etc. So the question we have to think ourselves is that standardization, will that move to yet another disruption? And our belief is the next disruption is cloud. So similar to how disruption happened in the Cray years in the 90s, how the operating system disruption moved the industry to Linux and then to standard HPC clusters, we think the next change is going to be cloud, or incorporating cloud in HPC. And let me talk about that and the reasons for that. So first, let's talk about HPC on-premises in general. Benefits of HPC on-premises. It's a well-understood model. We all understand HPC on-premises. It has an architecture that is really optimized for HPC, so I can really run my jobs well. What are the challenges of HPC on-premises? First, I would call out the diversity of emerging architectures. In the last few years that I was working with HPC on-premises, it was very clear that customers would ask me, what kind of system should I buy now? And with the appearance of CPUs, GPUs, KNL, FPGAs, customers don't know if they should buy a mix, a combination, split the machine, etc. And the problem with that is it leaves you with a hard choice when you make that choice. So if you decide I'm going to buy half CPUs and half KNLs, well, if KNLs is not the next thing to use, then you're left with a system that is not as usable. Also, you're splitting the architecture in terms of to run jobs, you have to run them on one half or the other half of the system. So that is a big challenge that people buying on-premise systems have. The other thing is matching the workload with the size of the system. When you buy a system that is fixed size, but you have a workload that has lots of peaks and valleys, it's a bit of a challenge to fit it in. What that means is you have to, when you have a high utilization, you have to wait in a queue to run on the system. The other thing is the time lag to acquire and provision a new system. Customers say typically it takes them 6 to 18 months. If new CPUs arrive, new GPUs arrive, it will take them 6 to 18 months until they're using them on premises in their facilities. The other thing that is important in my mind is performance decline over the years. When we look at curves of performance over the years, we see that in 10 years, you can buy for the same amount of money a system that is 100 times more compute power. So that's a lot. If nobody keeps the system for 10 years, but it'd be 100 times more powerful. 5 years, it'll be 10 times more powerful. So the performance decline is a problem. The system is great when you buy it, but then it starts declining. And then what customers are not wanting anymore is the big capital expenditure. When you buy a big system, you may be spending $5, $10, $20 million. They don't want to do that. If they could pay something more gradual, something more depending on the utilization, customers would be happier. And we hear that more and more. So over the last 2-3 years, I've been hearing that in my old jobs on premises, but in the last year, I'm hearing that more and more as I talk to HPC users. So here's an example of HPC in the cloud. And the first thing, Boeing, comes from our founders. They were working at Boeing in the design of the Boeing 787 wing, and they couldn't solve the design with the on-premise system because it takes 3 months to do it. And they really had to solve the problem to get the plane done. What they did instead is they went and got thousands of processors and solved the problem over a weekend. And that gives the impetus to think about starting a company like Rescale that enables you to do that all the time. Today, another customer of ours, Boom, which actually develops supersonic planes, is developing the complete plane totally in the cloud. More interesting than that is developing the complete plane totally in the cloud, and is using standard interconnects like Ethernet and standard architectures like what you find on cloud providers today. So to me, has been also a learning to come to Rescale to understand that significant work is being done on systems that don't require necessarily a high-speed dedicated interconnect. So what's HPC in the cloud and what are the benefits? First, you get instant access to unlimited resources, which means that if I need to run a big job, like in the case of the Boeing example, you can do it because you can get the processes you need at the time. You have a choice of architectures. What that means is I don't have to make the early choice of CPUs versus GPUs when I buy a system. I can run one job on CPUs, but I can run the next job, which could be machine learning on GPUs. So that way, I can really run applications on the best architecture for the job. And I don't have to make that choice up front and run always on the same architecture. The other thing that is interesting to me is that jobs run with no wait. And to me, rethinking HPC in the context of cloud was a learning experience over the last year, because I'm always used to having a scheduler submitting jobs to a big system that is kind of precious and expensive. But if you can get the processes you need when you need them, you don't have to wait. If you don't have to wait, you really don't need a scheduler because you don't have a constrained resource. So that's kind of an interesting way. You can submit jobs and run faster because there's no wait. And the other thing is you're not constrained by the size of a system. If you need to run a big job one time, which seems to be a problem with the customer, somebody shows up with a big job they need to run one time, how do you provision a system to run one time a big job? Well, you can always do that in the cloud. So what are the implications? You get faster innovation because you have an idea, you can run a big job and make a decision very quickly. You have shorter cycles of simulation, and that's key for people doing simulation in HPC because effectively reducing the simulation time means reducing time to market. And that's what people in industry using high-performance computing are doing today. And the other thing is immediate provision. No capital investment, variable size. So I don't have to wait 6 to 18 months. I can use the cloud today. And as I mentioned, things like job queue, system utilization, even downtimes are a thing of the past. So when you have to do a scheduled downtime of the system to upgrade or something like that, well, in the cloud you don't. The system is always available for you. So those are all benefits of HPC in the cloud. So here's an example. When you run on-premise HPC, you queue your jobs and then you run on the big system. When you run in the cloud, first you can submit the jobs in parallel, which gives you the advantage of not having to wait in a queue. But second, you have yet another advantage, that the jobs you're running in the cloud can be running on the appropriate architecture. Think about CPUs versus GPUs versus FPGAs, even architectures you may not use too often, but you may need sometimes. You're probably not going to buy the architecture and you settle for running everything on the same type of architecture, but here you're able to just run one individual job on that type of system. So I think that's pretty unique. Here's a couple of examples of customers of Rescale. So on the top, you have a company developing rockets in California. And what they do is they do their normal day-to-day work on premises. But before a launch, they have to do like 100,000 simulations. And when they have to do 100,000 simulations, if they serialize that in the on-premise system, it's going to take them months to go running, which is going to delay the launch. by using Rescale, they're able to do the 100,000 simulations in a parallel fashion, and they're able to do it 24 times faster. So that's very unique. The other example that I found quite interesting in analyzing actual use cases is Formula One. There's customers using Rescale next to the track in Formula One. So they are able to simulate the race in parallel to the actual race. So you have a simulated race, but you take the data from the real track and you're going to feed it into the simulation. With that, you're going to be able to run 3,000 simulations in one lap and make a call about changing the strategy of the race. These are things that are very unique to do, that you can do real time because you're able to have trackside access to cloud. So HPC in the cloud, if you go directly to cloud providers, you say you go to either Amazon, Microsoft, etc., Google. What are the benefits? First, you have choice of architectures. You have access to virtually unlimited resources. You have systems available today. You don't have to wait for provisioning. The engineers are not constrained by the size of the system. You run on the latest architectures, and you pay per use of hardware. So what are the challenges to go to the cloud today for most people? Well, you have to provision systems in the cloud. You have to build a software stack. You have to maintain and tune the applications that you're going to run in the cloud. You have to select the applications or the jobs, the workloads that you're going to move to the cloud versus stay on premises. You have to select the right architecture. You have to deal with multiple cloud providers, and each of them is going to have a different way of accessing their cloud. You have to manage software licenses on premises and in the cloud, and this ends up being a complex job because you may want to use a given application in the cloud and pay per use, or you may want to bring your own license, etc. And the other challenge I hear is cost control and consumption, which customer says, if I open up the cloud to my users, how do I know they're not going to spend millions of dollars in the cloud? So those are the challenges that we see. And this is where I wanted to say a few words of the Rescale platform. So what Rescale does is it takes advantage of the advancements of cloud that have happened and enables users to really submit high-performance computing, engineering type workflows, etc., directly from the main portal. So this, what you see in front of you, is basically the portal that Rescale provides a user. The user selects the software they're going to run by making a choice here in software. On top, you will see here the hundreds of applications that are ported and tuned. So we have about 250 plus applications ported and tuned and available on multiple architectures. And Rescale runs on top of all these cloud providers here. So run on top of AWS, on top of Azure, on top of Google, etc. What that means is you as a user are going to select an application, like you want to do computational fluid dynamics. You're going to select your application to run. Rescale is going to recommend what's the best architecture to run that application, and it could be on one of the multiple cloud providers, and it could be on premises, and that's a concept of hybrid also to the right. You're going to submit the job. You're going to say how many processors you want, and then you're going to choose if you want to bring your own license and use that for the software, or you're going to pay per use of your license. So think that we're taking a step back to what does the user need? The user suddenly needs to run a job that needs 1,000 CPUs and then nothing. Well, what this is going to do is enable you to very simply select the application to run, get the hardware you need, the software you need, the license you need in a portable, optimized and tuned way, and you're going to run on the appropriate architecture. So every job is going to be run in this way. So when you use Rescale, we have a user and an administrative portal. You're going to be able to administer users and resources if you're on the administration side of the house. You're going to be able to manage software license, application software. So it says Rescale does these things for you and enable you to manage users and softwares and permissions and etc. We're going to support the multiple cloud providers. That's a key. Most customers say, I don't want to go to a cloud provider and be locked in. I don't want to write my scripts to work on just one cloud provider. By having access to multiple cloud providers, you have the ability to run always on the best possible architecture for the job. We can also support the multiple network providers, manage data across locations, offer security. That is a challenge for people. How do you do security in a hybrid environment, in a multi-cloud environment? And then how do I submit jobs on-premise and to the cloud? So this is restarting computer. I don't want to restart computer, sorry. Okay. So let's go to the next slide. And here we see how we implement the platform. First, on the left, you have the cloud native, which is the example of Boom I just showed you, where you have access to systems in the cloud, and you're able to submit jobs totally in the cloud. And we have a number of users doing that today. We have access to people. We have people doing on-premise HPC using the Rescale platform. And we have, for example, universities that have chosen to use Rescale as the way for all the students and researchers to access the on-premise system. And that simplifies the access for new users, that simplifies their administration, etc. And many times when people go on-premise, they're thinking already about hybrid. And hybrid gives you the ability to run jobs on-premise, to submit jobs on-premises or to the cloud, and gives you the best of both worlds when you do that. Here's an example of a Japanese university that has chosen Rescale for a full hybrid deployment. So what they've done is they have Rescale as the main interface for their users. So any users who want access to their HPC system uses Rescale. They're able to submit jobs on-premise, and they're able to administratively decide which systems can people use when they have multiple systems. But they're also able to allow people to submit jobs to the cloud. You can even make choices about, have budgets or which cloud provider, which type of architecture you allow. I hear customers that say, well, we have CPUs and we don't have GPUs. Well, you may authorize a group to use GPUs in the cloud immediately. The advantage would be when GPUs are available, like V100s came out late last year, they were immediately available in the cloud. We at Rescale, because we support multiple cloud providers, including the standard and some boutique ones that do bare metal and supercomputing centers, we enable people to have access to the latest hardware right away. So you may want to try some application using the latest GPUs. You can do it with Rescale, but it'll take you a long time to have a provision in-house. So here's how we do hybrid HPC with Rescale. So what you see now on the left here is what's the screen that a user will see. This one is a bit more of a complex workflow than the other one, but effectively is what I mentioned earlier. You select the application you want to run, and at the bottom, what you see is different architectures where you can run it. Rescale recommends where to run the job. The recommendation could be on-premises or in the cloud. And then you say how many processors you want. It'll show you here on the right how much is it going to cost per hour. You can say you want to pay per use of the software. We have agreements with many of the ISVs to use their software pay per use. Actually, when we look at the top 40 softwares and utilization on Rescale, 33 of them you can either pay per use or they're open source. And only 7 of them you have to buy your own license. So we see that changing in the industry, that more ISVs are offering pay-per-use. So what we enable to do is the ability to make a choice. If you have a license, you use it, but if you don't have a license, you can do pay-per-use. So to submit a job on premises, what we do is we integrate with your job schedule. So if you have a system in-house that has a job scheduler, that's a simple interface, and we support the major job schedulers today. After you do the connection, you can add the cloud access. When you do that, now you have both possibilities. And as I mentioned earlier, you as a user can select an application to run, and you'll be recommended to run either on premises or in the cloud. So that becomes very simple for users that are not that familiar with HPC. If you're a user that are more familiar with HPC, and we see both types, the people who've been for many years in HPC, like scripting, Well, for those users, we have the API and CLI. So effectively, you can write for the Rescale API/CLI, and you're able to now have one way of scripting your access, your jobs, that now you can use on premises, in the cloud, across multiple cloud providers, including standard cloud and supercomputing centers. So that gives you a broad range of access with just one way of writing scripts. You don't have to write different scripts when you go to a cloud provider or where you run on premises. Finally, one thing you can do is, as you start moving some of the workloads to the cloud and you have free cycles on premises, you can make your systems available on the Rescale cloud. You're already connected to the Rescale cloud by having made the connection before. You're just not opening up the system for other people to use it, but you can. So universities tend to like this because they're able to offer their system to other universities, do collaboration across research centers, or even do access for industry partners, and they can get money back for their utilization. So imagine you're a university, you get customers in industry that use your system, you get some money back for that, and now you can use other architectures across the Rescale cloud with that money or that credit you got. So that's another possibility that you have in the hybrid world with Rescale. So I mentioned that you have one way of accessing and one way of administering all systems. Here's a screen that is showing the administrative portal. In this screen, you're able to set budgets, limits, groups, permissions, etc. So if you imagine an on-premise administration system of today, well, when you go to Rescale and you start using Rescale today, you immediately get an administration system across this multi-cloud environment. And you can create users, permissions, and you can do all the things you do in an enterprise administration system. So we think this is, in a sense, a new approach to HPC. It has transformative benefits. When you think about the platform, it gives you hybrid cloud with on-premise support, a multi-cloud environment. The fact that you access the latest architecture in a way, you have the applications ported and tuned, that makes the whole picture a bit different than other offerings. So we don't have any hardware ourselves. What we try to do is think about the user and enable the user to have the best possible match between the applications they need to run and their systems on premises or in the cloud. The recommendation that we do, and this is something we're going to continue to evolve, it's quite interesting because most times I don't know what architecture is best for me to run. The fact that we're able to constantly benchmark and tune our stacks, we're able to make a recommendation, and as we have more people running, and we've seen growth of about 30% per month in terms of the utilization of our systems in the cloud, our core hours. So the more data we have, the more we're able to make finer and finer recommendations. Recommendations don't have to be perfect, but at least you may want to know what applications are going to run on premises, what are you going to run in the cloud, which ones are going to be most appropriate for one type of architecture like CPUs versus GPUs, etc. The fast learning curve I mentioned, the pay-per-use for hardware and software, that's a promise of cloud. And ideally, you want to come to a point that you come to the cloud, you just pay per use, and the one platform to administer all systems, to access all systems. Here's a question I get often is, but how much does it cost me to run on-premise in the cloud? And people often say, if I'm going to buy a 32-node system on premises with InfiniBand, can you quote me that 24/7 in the cloud? And I often say, well, that's going to be more expensive in the cloud, but that may be the wrong question. We need to look at the workload. So here's an example of a real customer of us from the automotive industry. And this customer has this workload. This is the actual workload they needed to run. And they consider buying a $4 million on-premise system, which will give them this much capacity. So they're able to either run here sort of underutilized or be overutilized in these parts when they have a peak workload and be waiting in a queue. And they buy a $4 million system. Instead, they decided to use Rescale, and they pay between $50 and $100K a month. And what they get is exactly what they request. So if they need in a peak 1,000 CPUs, that's what they get. but here they may need 100 CPUs. Well, that's what they get. So the interesting thing is they're always running with no weight. They paying 50 to 100K. They did not buy the on-premise system. The on-premise system would have costed $4 million. The depreciation of that over 3 years would be 111K per month. Well, they spending 50 to 100K. They getting a better service. They finishing the simulation sooner. So I think that's the interesting question. It's not compare hardware and hardware. Compare the service you're going to get running your workload on premises or in the cloud. When you go to hybrid, you have a mixed alternative, and you can make a call now. And what I say to people is cloud is an all or nothing. You can add cloud today. If you're going to wait for the next time you're going to buy a $5 million system, you're going to buy another $5 million system. If you start trying cloud today and incorporating cloud and extending to the cloud, you're going to be able to learn what are the applications that work best on premise, what are the applications that work best in the cloud. And by the next time you buy a system, you may decide to buy a smaller system and have the best of both worlds, have the best match between having enough system in-house to run the workloads that need to run on premise, but have access to the cloud to run the peaks and valleys of the other workloads that will run better in the cloud. So the final thing I was going to say is one thing that we don't talk a lot about, so I thought I would, is we have a team of people that have been doing HPC in the cloud for the last 7 years, since 2011. So these people have applications expertise, they have PhDs in engineering, they know exactly how the applications work and the domain works, but they understand the domain, they understand the application, they understand HPC, but they understand HPC in the cloud. And having done it since 2011, people know how to optimize the jobs to run properly cloud providers. With that summary, my view is hybrid is going to be here for a while. Cloud today may be about 5% of the HPC world, and on-premise may be 95%. Some changes that are interesting. I was at ISC a couple of weeks ago. One of the analysts told me that last year cloud grew 44% in HPC. Well, that's a significant number. Another analyst told me the number of customers that are testing things with cloud has grown to, he didn't give me a number, but he says most customers are testing cloud. My experience talking to people is they are, because they're really interested in trying cloud. It's not a jump, it's not all or nothing. You're not going to go from on-premise to the cloud. So I think it's going to be on-premise, you're going to run the workloads that are constant, that have a single architecture, and the benefit from that. But in the cloud, you're going to be running the workloads that will take advantage from the peaks and valleys, from the variable architectures, and to run with no weight. So you're going to move some projects to the cloud. So I think you're going to be in this hybrid world. We're going to live in this hybrid world for a while, where a system on-premise is incorporated with a system in the cloud is going to give you the best alternative. With that, I think I finished my presentation, and I'd like to open it up for questions.
Thank you, Gabriel. So as he just said, that wraps up our presentation portion of the webinar. We're going to move on to question and answer. So if you hadn't had a chance to type in your question yet, I see that a couple questions have actually come in. Now is a good time to do that, and we'll go ahead and do that. Get started there. So while you're typing in your questions, I want to point out a special offer as a thank you for attending today's webinar. All of you will receive a $20 Rescale credit that is valid for hardware usage on the Rescale platform. You'll receive the code in a follow-up email from me within a week, and you'll need to sign up for the Rescale account if you haven't done that already at www.rescale.com/signup, no hyphen or space. And then my email will contain further instructions on how you can apply that code. I also want to invite everyone back to our next webinar, the Rescale product roadmap, with our product manager, Dave Anselmi. Alrighty, so we're going to go ahead and start the questions now. I'm going to pick probably the best 2 or 3 here. I think that'll cap it pretty well. But if you have another one, please don't hesitate to send it in. All right, so first up, this comes from James. How long does it take to get Rescale Hybrid set up on my site with my scheduler? We use PBS. Gabriel, do you want to take that?
Yeah, we had experience doing those. I would say first, typically you can get access to the cloud immediately. So when we use Rescale totally in the cloud, yeah, absolutely no wait. You can start right away. Connecting to the in-house scheduler normally is a process for us that takes about 2 weeks, and we have to work with you in some of the details of the connection, and we get it done pretty quickly.
All right, thank you, Gabriel. Next question comes from Robert, same name as myself. Hi, Robert, how you doing? It says, why should I use the Rescale platform to burst to the cloud instead of my job scheduler?
Well, that's a good question. Often people, and even before I joined Rescale, I've been thinking about the ability to just do cloud bursting. I'm running from the scheduler, and I submit jobs on premise. If I have the ability to, when capacity is almost full, I overflow to the cloud, that sounds great. Well, the reality is the more I analyze the problem, I see some issues with that. First, it connects you to the old model that you're using, where you have a scheduler and a system on premise. Second, at the moment you want to burst to the cloud, so you're not taking advantage of, say, multiple architectures running with no wait, etc. And then at the moment you're going to submit a job to the cloud because you're almost full, it's unclear if that's a right job to move to the cloud. So you're going to be moving something to the cloud, and it may be running in an unoptimized way. So we think our approach would take it, we can actually do the approach of bursting to the cloud the way you mentioned. We think our approach of taking a step back and making selections up front of what are the workloads that are going to move to the cloud, making recommendations of what are the best workloads to run in the cloud versus on-premise, gives the best alternative in terms of how you're going to match applications to the best architecture in on-premise and in the cloud.
Okay. The next question is actually, a couple people asked this, so I'm going to combine Bernd and Camila's question. Bernd asks, how does data transfer work for large simulations? And Camila asked, what kind of link speed do you need to run HPC in the cloud? I figured I'd package those together for you, Gabriel.
Sure. So the first thing I would say is data movement is something to consider when you're going to run on-premises and in the cloud, and link speed make a difference to that. So maybe we can divide the world in a few ways. One way of running in the cloud is if the data that you need to transfer is small. Sometimes the input files are small, but the output files are big, for example. That happens often. You might be able to just transfer input files, run in the cloud, but then you may not want to transfer back the output files. In that case, we have the ability to just leave the data in the cloud and do remote visualization and manipulation of data in the cloud. If you're doing that, you can do that with a relatively slow link speed. We often do use HPC in the cloud with regular internet using Wi-Fi, and that works just fine if you're not moving large amounts of data. When you're moving larger amounts of data, you may want to take advantage of other offerings we have that are more dedicated links. So you can have a dedicated link from your office to Rescale, and in a sense to the cloud providers, so you're able to move data at much higher speed. And what we're learning is if you're moving up to gigabytes, the internet is fine, but if you need to move more like terabytes, the dedicated links work better. So part of the trick of running the cloud is, if the data is big to be moved both ways, maybe you want to have that data in the cloud and run in the cloud, or that data on premise and run on premise, or you want to have a high speed link enough to move terabytes of data both ways. But in general, what we do is early on, we would sit down with the customers to understand what kind of workloads they have, how much data they need, and propose the best assignment. And then over time, you're going to get the best recommendation of where to run.
Thank you, Gabriel. So I'm going to tack on another question to that. You mentioned moving up to gigabytes and terabytes. Jerome asked, what about data movement? He mentions he has a petabyte of data to move. How do we handle that, or how do you envision we would handle that in the future?
If you have a petabyte of data to move, normally the offering that exists is you can move one-time data, and the easiest is to ship a disk, and you install that data in the cloud, and after that you use the data. You don't want to be moving petabytes of data back and forth between on-premises and in the cloud. So either you continue to operate with that data in the on-premises, or you move it one time to the cloud, and after that you run totally in the cloud.
Okay, I think that's all the time that we have today. I want to thank Gabriel again for your wonderful webinar. We are out of time, so as a reminder, we will be sending out a promo code and the recording this week of the webinar, and the recording will also appear in our newsletter at the end of the month. Bye-bye, everyone, and thank you so much for attending. We'll see you next time. Bye-bye.